Pythagoras' theorem. Pythagoras' theorem is c squared equals a squared plus b squared, where the c represents the longest side of the right angle triangle, also known as the hypotenuse, and the a and the b represent the other two sides. Pythagoras' theorem, this formula, is given to us in the formula books. So very, very important before we start having a look at some examples. It can only be used with right angle triangles. So here we have a triangle with a right angle. We know it's right angle because it has a little square. And here we have another triangle with a right angle. Again, it has a little square. Sometimes it's written as an L. The other very important rule with Pythagoras' theorem is that the c in the formula must be the longest side, which is the hypotenuse. Okay, so here we have a right angle triangle, and how we started is we label the sides of our triangle. So the longest side has to be labelled as C, and the other two sides get labelled as A and B. It doesn't matter which way you label the A and the B, so long as the C is the longest side. Then we write out our formula, c squared equals a squared plus b squared. Then we substitute into our formula. So I'm going to swap the C for 5 because it's the longest side, so I get 5 squared equals, I swap the A for x because I've labelled the x as A, so I get x squared plus, I swap the B for 4 because I've labelled the 4 as B. 4 squared. 5 squared is 25 is equal to x squared plus 4 squared is 16. So 25 equals x squared plus 16. We're going to bring the 16 over the equal sign, it becomes minus 16. 25 minus 16 is equal to x squared. 25 minus 16 is 9, so 9 is equal to x squared. So the squared comes over the equal sign and becomes square root. So we get x is equal to the square root of 9, which is 3. So this unknown side that's labelled as x is actually 3 meters. So this triangle is actually a 3-4-5 triangle. A 3-4-5 right angle triangle to be specific. So it's one of the triangles that we can learn off by heart. So if we ever have two sides, any of which being 3 and 4, 3 and 5, or 5 and 4, we always know what the other one is going to be if it's right angled, because this is the 3-4-5 triangle. So it's good to learn that off by heart. So if we have a look at our triangle over here on the right, so we have 30, 40 and x. So straight away I know that this is going to be 50 centimeters because again it's our 3-4-5 triangle. But I'm going to work it out anyway. So I label my triangle A, B and C, C being the longest side, A and B being the other two sides. I write out my formula, c squared equals a squared plus b squared. I substitute into my formula. I swap the c for x, so I've got x squared is equal to, I swap the a for 30, so 30 squared, plus I swap the b for 40, plus 40 squared. X squared stays as it is, that's equal to 30 squared, which is 900, plus 40 squared, which is 1600. 900 plus 1600 is 2500. The squared comes over the equal sign and becomes square root. The square root of 2500 is 50. So x is equal to 50 centimeters, which is what we said at the start, because remember it's our 3-4-5 triangle. So we can work that also for 30, 40, 50. We use Pythagoras' theorem when trying to find an unknown side of a right angle triangle when given the other two sides. We use SOHCAHTOA when trying to find an unknown angle of a right angle triangle when given two of the sides, or when trying to find an unknown side when given one side and one angle. So to summarize, we only use SOHCAHTOA when angles are involved. Pythagoras' theorem and SOHCAHTOA can only be used with right angle triangles. So in the next video I'll show some examples of SOHCAHTOA.